Morning guys, happy Monday to you. I want to start this week out by going over wastewater management. A couple of the things that we'll touch base on here. Reuse, recycle, discharge, and treatment, publicly owned treatment works, on-site and decentralized wastewater treatment systems, and how do septic systems work. Soil tests and the reasons for failure. Let's talk about the reuse and recycle and discharge and treatment. Most wastewater from a building is considered to be sanitary wastewater and can include human waste, cleaning solutions, oil and grease from the cooking, food, particles and soil from cleaning clothes and floors. Commercial establishments can also discharge metals, acids, and bases and small particles of plastic, glass, stone, and etc., depending upon what your business is. What happens to wastewater that is discharged from a building, though? Wastewater is not safe to drink, and discharging this water directly into the environment, onto the ground or into a water body, whatever, can pose health and safety problems. After all, this water is part of the wastewater cycle and will eventually make its way into a source of water supply. So the wastewater has got to be properly managed to protect human and environmental health and safety. Most of the wastewater generated within a residential or a light commercial building, though, is called gray water, and it can be reused for non-drinking purposes such as landscaping or flushing toilets. The water can be stored until needed, but while it's being stored, it's got to be treated because it can become stagnant and breed disease and so forth in it. Recycling wastewater. Wastewater can be treated on-site or off-site and reused for non-drinking purposes. In a closed-loop system, we'll talk about a closed loop and an open loop. Closed-loop treatment systems are often used to capture, treat, and reuse wastewater on-site. Wastewater reclamation, though, involves treating the wastewater and using it for different purposes. Closed-loop systems are often used by businesses like car washes and places that have pressure washing on-site, like for tractor trailers and stuff like that. An example of wastewater reclamation, though, would be using water treated by a municipal water treatment system to irrigate public property like golf courses and things of that nature. Discharge and treatment. Wastewater is transported to an on-site or off-site treatment facility, treated, then discharged into a body of water. Publicly owned treatment works, POTWs, or decentralized wastewater treatment systems. Those are the two we'll talk about. Publicly owned treatments, owned by a state or a municipality, stores, treats, recycles, and reclaims municipal wastewater. They're talking about a city sewer system. It includes sewers, pipes, and treatment plants. The picture they're showing there is of a facility near Atlanta, Georgia. The treatment includes primary treatment, which is screening and settling. Secondary treatment, which is biological treatment, in which activated sludge eats pollutants. And then the disinfection, which kills bacteria, viruses, and protozoa. Minimum pipe sizes: 3-inch or 4-inch for a residence, 6-inch for a multi-family or a commercial facility, and then 8-inch minimum for industrial facilities. The depth 2 feet below the lowest floor with sanitary sewage drainage. And it's got to be below the frost depth, which makes it even lower in northern states. The sewer lateral slope, it's got to have a 2% minimum slope, equals 1/4 inch per foot drop. Separation, 10 feet minimum horizontal distance between the water and the sewer lines. Sewer lines are at least 18 inches below the water supply lines, though. Here we're looking at a picture of a sewer lateral slope. Because wastewater flow is typically dependent on gravity, wastewater pipes got to slope down in the direction of flow in order for the wastewater to be transported to the sewer main. A copy of this sketch should be provided in your notebooks. If you'd like to put that in, that would be good with the sewer slope chart here. Crown elevation refers to the elevation of the top of the pipe. And OD, of course, stands for outside diameter. On-site and decentralized wastewater treatment systems. Municipal sanitary systems, POTWs, are preferable to on-site systems. But if no municipality system is easily accessible from the site, an on-site system is going to be the only option. Because if you're building a house, you can't afford to tie into a sewer system that's 4 miles away, so you've got to have an on-site system. On-site systems collect, treat, and disperses or reclaims wastewater from individual residences, businesses, or small clusters of building. They're used when no municipal system is available, and approximately 25% of single residences in the United States and 35% of new developments use an on-site and decentralized system. These are also called septic systems or private sewage systems, individual sewage treatment systems, or on-site sewage disposal systems, or a package plant. Okay, more than 40% of the population within the red states use septic systems. South Carolina, the location of the Palmetto Project, is a red state too. National water quality problems. 10 to 30% of systems fail annually, and at least 10% of systems over 30 years old do. Failing septic systems have caused a water quality problem throughout the United States. Between 10 and 30% of septic systems fail annually, and then when the septic system fails, sanitary wastewater may leak into nearby surfaces or groundwater sources. Such failures expose people, animals, vegetation, all to unsafe contaminants. These pictures show wet areas and septic drain fields, and saturated soils allow raw wastewater to percolate to the surface. So the components of a system: proper siting, proper installation, proper operation and maintenance, and proper design. These are all the things that one has to take into consideration when designing a septic system. Conventional system has a tank, a distribution box, and a drain field, also called a leach field, and then proper soil, which is a pre-approved sand base. A septic tank holds liquids for about 2 days. Then the sludge and the heavy solids settle out. Then scum, grease, oil, floating debris rise to the surface. And then anaerobic decomposition breaks down some solids. Tank should be pumped out regularly and maintained. Those are the commercials you see on TV for Rid-X. The image on the left shows the internal workings of a septic system. This picture on the right shows the installation of several septic tanks for a motel in Florida. So how does a system work? How does a septic system work? The wastewater is discharged from the septic tank to the distribution box. The distribution box disperses the liquid to the drain field. The drain field is made up of perforated pipes on a bed of gravel which are buried underground. The wastewater filtrates the soil through the soil surrounding the drain field. The intent is that the soil filters or treats the wastewater before it enters the groundwater or a nearby body of water, thus acting as a natural filter. Some soils can't adequately accept or treat wastewater, especially here in North Carolina with the clay. That does not work well at all. Most jurisdictions require that the soil on which the septic system will be built is evaluated to make sure it can provide adequate treatment, and you should check with your local building department to determine how the soil must be evaluated. In some cases, local officials must perform the testing. Pretty much, I don't know of any systems or any municipal systems that don't have to do the test. One example of a soil evaluation method that is required to percolate, do a perk test. Perk test is one method to establish the rate of water infiltration into the soil. So there are many different ways to perform a perk test, but the local building department may identify a specific testing method. A perk test basically consists of digging several holes in the proposed locations on the drain field, filling the holes with water, and then timing the drop of the water level to determine the rate of infiltration in each hole. The length of the drain field is based on the infiltration rate, although some municipalities still require a perk test in order to obtain a permit to construct a septic system. Perk tests have been found to be unreliable in certain cases, especially during a season of heavy rain or heavy drought. Many jurisdictions no longer even allow the use of perk tests to determine infiltration rates. They make it mandatory to bring in certified soils in order to put in a new septic system. The reasons for the failure, let's talk about a couple of those. The top picture shows a waterfront property with a high water table. This property is not suitable for a septic system at all. The ground is too wet all the time. Proper maintenance is essential in order to keep the on-site decentralized system working properly. So the second picture shows a pump truck removing the sludge and scum from a commercial septic system. So the reasons for failure: poor soils, drain field with high water tables, systems undersized, poor construction, poor maintenance. So these are the things that all make up the resources of a wastewater management system. We've gone over reuse, recycle, discharge, and treatment, publicly owned treatment works versus private, on-site and decentralized wastewater treatment systems, how septic systems work, soil tests, and reasons for failure. Today I would like for you guys to go over the questions on this page, find the answers. They've been given to you, but you can either find them here or you can use Google. I want you to create a new Google Doc labeled wastewater and then share it with me when you've got all the questions answered. All right? And I'll look for you tomorrow. Have a great day, guys. Any problems, you need any help, contact me and we'll figure out how to solve this problem.